Hello, everyone. Welcome to today's session. This is Dr. Yolimatics, and today we are going to begin some series of lessons on trigonometry. And today we'll look at our first lesson, which is going to cover the objectives that you are seeing on this screen. So I have added my details also on this screen in case you may be interested in having some private sessions in both pure mathematics and physical sciences. You can contact me. Both the number just works both for calls and on WhatsApp. You can find me on that number, or in case if you can email me your message via my email there, that will also be fine. But anyway, if you haven't subscribed to this channel, I'll advise you to do so right now. Click the subscribe button so that you may not miss any of the oncoming videos for this year. Okay, that's it. So let's begin. So the first thing that we're going to discuss first, we are going to approach trigonometry starting from its introduction, which is always done in grade 10, moving all the way up until we cover everything that is also covered by grade 12 students. So the first thing is defining angles, is the first item of our discussion today. So trigonometry is a subject which one can define as the study of angles and functions that accept those angles. So that's one way of defining this subject. As although many different mathematicians, they can define it the way they find it suitable for them. So for me, trigonometry is just the subject which deals with angles and functions which can take up of those angles and produce real numbers out of all that. So which means it's very important to understand the fundamentals of this subject, which is angles and the functions that accept those angles. So the first thing that we're going to do now is to define what it is that we call an angle in mathematics. So what is an angle? So an angle is defined as the measure of a tan in many different books. You see, so many books, they define the angle as just the measure of a tan. So I'm not going to take it as my own definition of an angle in mathematics. So what I'm going to define as an angle is this. So an angle is defined as the measure of the inclination between two lines. So if you have any two lines like the ones that we are seeing here, where you can refer to this as line 1 and line 2. So the measure of the inclination between any two given line in space is what I define as an angle. You see that? So that's what we're going to use in the whole of this chapter, that an angle, every time when you refer to an angle, you should always know that it is the measure of the inclination of any two given line in space that intersect. Actually, yeah. So we need those two lines to intersect in space. So any two lines that intersect in space are always associated with this concept of the angle. And we define the angle as the measure of the inclination of the two lines, or between the two lines, like that. You see. So this thing that we call the angle, there are many symbols that we use for referring to it, and the one of the common ones is theta. So the Greek symbol theta is one of the symbols that we use every time if I want to represent an angle, like that. So these things that we refer to as angles can either be positive or at times they can be negative. It all depends on how you measure these angles. So this inclination between two lines, there is a device that we use to measure what is the inclination between any two lines. And this device is called the protractor, and it's one of the devices that can be found in any standard mathematical set. So I hope everyone is familiar with the mathematical set or the drawing set, which consists of the compass, 15 centimeter ruler, 30, 60 set square, 45 set square, and then the divider, and then the protractor. So the protractor is a device which is which has a semicircular shape, and it's labeled with numbers along its circumference there. So that's the device that we use every time if we're interested in measuring this quantity, which we refer to as the angle. So angles in real life, they're always positive, but in mathematics, usually angles can either be positive or negative. But that does not then mean, especially for physicists, they might think then an angle is something that has to become a vector in some way, because it seems to be something which has these two properties, both magnitude and direction. Though it does have that, an angle is not usually categorized as a vector in physics. You see that it's more like just the concept of work in physics, which can either be positive or negative, but is not a vector at all. You see, so the reason why we end up with this issue of having angles that can either be positive or negative is because we have a convention that we stick to as mathematicians, and this convention goes as follows. So if I want to measure the angle between any two given line, the measurement of angles is always done in an anti-clockwise manner. So if I want to measure the angle of inclination between these two lines, I can measure starting from L2 and then turn up counterclockwise in that direction. So if I measure angles this way, then this is what I refer to as a positive angle. So if you measure an angle going in a counterclockwise direction, this is what we refer to as a positive angle. But then suppose you measure angles this way. You decide to measure an angle this way. This time you are asked to find the angle between L lines L2 and L1, and then you measure starting from L2, but then decides to go this direction now. So when you decide to go this direction, this one is what we refer to as a negative angle. You see, so angles that are measured counterclockwise, they are positive, while these angles that are measured clockwise, they are negative. So the positivity of angles, the positivity or the negativity of angles is due to the direction in which one chooses to measure the angle. So if one chooses to go that way, it becomes positive. If one chooses to go that side, it becomes a negative angle, like that. So I think now we are quite clear on the definition of angles. Then now let's talk about the units for measuring angles. You see, so angles are measured in degrees or the radians. So the two common units for measuring angles, we have what we call the degree, and we have what we call the radians, like that. You see, so if you have an angle, if you measure an angle, let's say you use a protractor. So protractors are always calibrated in degrees. You see, so protractors, these devices that we use for measuring angles, they are always calibrated in degrees, which means when you use a protractor to get angles, you are always going to get angles that are in degrees all the time. So there's no protractor so far which works in the radian mode. So the radian mode is a unit that one can play around it when you have a scientific calculator. That's where you can get to experience this unit and see how it relates with the degree. So what we are going to stick to at this level, all angles that we're going to be discussing in chapter, they are going to be angles which are in degree format. We are not going to associate ourselves with the radian mode for now. So all calculators that we're going to use, you have to make sure that they are set to the degree mode so that they show a small d there at the top, showing that all angles that they provide, they are in degrees. You see, so we're not going to concern ourselves with all that. So now what you have to know is to distinguish between an angle that is measured in degrees. So if an angle is measured in degrees, you see, so if you have an angle that is measured in degrees, this is how you write it. So let's say you measure an angle with a protractor, then you get that is 25. So if it's in degrees, that's how you write it, you see. So for angles in degrees, we use this at the top, you see, to signify angles in degrees. But if theta is in radians, this is how we write it. So you will say 0.2c. So for angles in radians, use to see like that. Or if you write an angle in mathematics without including this, not for the degree mode, we always assume that it is radian mode. So you might find that the SI unit for angles is always the radian, and it is the most fundamental one. It's just that in mathematics we prefer this one, but this one is the most fundamental. And in mathematics there is this convection. If you do not write this not symbol, we assume that whatever you're stating is in radians. So if you say just theta is 25 degrees, some examiners may penalize you for that because they think you are suggesting that the angle is 25 radians, not the degree. So be careful that you always put that note all the time when you're specifying angles. Then let's move on to the next category, which is the classification of angles. You see, so these objects that we call angles, or these quantities that we call angles, they can be classified into 4 categories, you see. So we have 4 categories of angles, which I'm going to represent here as follows. So we have different classes of angles, which are split into 4 categories. We have what we call acute angles, then we have what we call obtuse angles, and then we have what we call reflex angles, then we have what we call compound angles. So all the angles that we deal with in trigonometry, they can be classified under these 4 headings, like that. So now let's understand what it means for an angle to be acute, obtuse, reflex, and compound, like that. So an angle theta is said to be acute when it ranges from 0 and is less than 90 degrees, you see. So any angle which is less than 0, which is greater than 0 and less than 90 is called an acute angle. Then any other angle which is greater than or equal to 90 degrees but less than 180 degrees is called an obtuse angle. So any angle which lies within this interval, we refer to that as an obtuse angle. So one can put subscript there to denote this theta A acute, obtuse, then we have theta R for reflex. So reflex angles are those angles which are greater or equal to 180 but less than 360, like that, you see. So anything which is greater than 60 is called a compound angle, like that. So when we deal with angles in trigonometry, we have this classification system which everyone has to be aware of, which classifies angles under these different categories, like that. So it's good thing to also be aware of this kind of classification and understand also the interval bounds for each system. So even if you use the greater equal to for those, it doesn't matter, as long as an angle lies within this interval, that they will be classified as accordingly as shown by that table there. So these are one of the things that you should understand when it comes to angles. Then the last part of this session is drawing angles in Cartesian planes. So we want to learn how one can draw angles in a Cartesian plane. Easy. So angles, um, they can be drawn or can be represented in a Cartesian plane. But when we are trying to draw angles in a Cartesian plane, we do not actually treat the plane in the same way we do when we are representing some coordinates in a Cartesian plane. So it's a different thing. So the Cartesian system that we use for representing angles goes as follows. So I'm going to show both two versions. So we have two versions of Cartesian system that I use for drawing angles. So we have one for positive angles and one for negative angles. So I'm going to draw both of them here so that you can see the distinction between the two. So instead of labeling along these x-axis and the y-axis, when we are drawing angles in a Cartesian plane, we do not label here x and there y, but what we do, we just label here as 0, which means the positive x-axis acts like the 0 of the reference frame that we're using, like that. Because remember, every time when you're measuring something, there has to be a starting point, which we call the 0 of the reference frame. So the 0 of this reference frame for drawing angle is the positive x-axis, like that. Then this tip is usually labeled 90 degrees, which means that all angles that range or lie within this region, they should be always between 0 and 90 degrees. And then here we have 180, then here we have 270, and then here we have 360, like that. So this can proceed so on like that: 360, 450, then 540, then 630, then 720, on and on up until you get to the highermost angle, which can cater for all the angles that you want to represent. Then for the negative, the positive x-axis still becomes the 0, but now this one becomes the negative 90, and then this one becomes the negative 180, then this becomes the negative 270, then this becomes negative 360, like that. Then you can also rotate if you want, so say negative 360, negative 450, negative 540, then negative 630, then negative 720, or all like that. So we have these two systems that we use every time for representing angles, like that. So every time if they say draw this angle in a Cartesian plane, you should always know how to create your reference frame in this manner that you see on screen. So then how do we make use of, or how exactly do we then draw angles in a Cartesian plane? So angles in each of these frames that we are seeing here, they are representing by a straight line which starts from the origin or from the intersection of these two reference lines. And these lines then, they should lie within the respective region. So these regions that you see there, remember, if you draw a Cartesian plane, it will create four rectangular regions like that. So these regions, we refer to them as the quadrants. So this here is called the first quadrant, and this here is called the second quadrant, and this here is called the third quadrant, and this here is called the fourth quadrant, like that. So even here, same thing: first, second, third, fourth. So the labeling of quadrants, it always goes counterclockwise in that direction. So one of the things then that you can be asked in mathematics is you can be given an angle and then they say represent that angle in a Cartesian plane. So how do you represent angles in a Cartesian plane? So now let's illustrate by just drawing a few. So one of the typical problems that one can get is you can be given an angle of 110 degrees, and then you can be asked to draw that angle in a Cartesian plane. So how do you go about that? So in order to to draw angles in a Cartesian plane, what you simply do is you go and study your reference frame, and then what you're going to look for, you should look for a quadrant in your reference frame which bounds the angle that is given. You see, so by bounding, it means that angle must lie within that quadrant. So if we come and look at this second quadrant that we have here, we see that it covers for all angles that lie between 90 and 180 degrees. So it means this 110-degree angle that I want to draw must lie within this quadrant. And once you have recognized which quadrant will the angle lie, you can simply now take your ruler and draw a line in that quadrant which starts from the origin and goes away like that. You see. Then, to label the angle, angles are labeled this way. So first, angle is represented by the line. So this line that you see here, we call this the terminal arm. So this line is called the terminal arm. So angles are usually represented by terminal arms, but it's not only the terminal arm that represents the angle, because one should also show how many turns one should take to reach that terminal arm, so that the turn that one makes is equivalent to 110 degrees. So since this line acts as our zero line, it means you're going to draw the turn starting from here going up until you reach that line. So it means this is our angle 110, like that. So you can also be asked to say represent maybe an angle of 290 degrees also. So how will you represent 290 degrees? So to represent 290 degrees, same thing, you will come and recognize the quadrant which bounds 290. So the fourth quadrant seems to be the one that bounds 290. So it means to draw 290, I'll come and say, okay, 290 lies in this quadrant, and then I show it by my line. Then now I have to show how we should turn in order to reach that line. So in order for us to turn to reach that line, it means we have to move from here, come here, then go there. So we'll have turned 290 degrees like that. So this is simply how we represent angles. So the other thing, now you can be asked to represent negative angles in a Cartesian plane. So how do you represent a negative angle? So it is the same logic as what we did here. It's just that here you have to see that the labeling now is done clockwise, while here the labeling was done counterclockwise. So if you want to draw, suppose you are given the angle negative 470, how will you construct that angle negative 470? So in order to construct negative 470, you will come and say, okay, which interval bounds 470? So I see that 470 lies within this third quadrant. So it means the terminal arm that is to represent this angle has to lie in this region, and I'll just draw it anywhere like that. Then now I have to show how many turns actually describe this line, you see. So how many turns are required for someone to make a turn of equivalent to 470 degrees. So we see that now, if you come and do this, definitely one can tell that this turn cannot actually give us the angle that is being drawn. So it means at first we are going to make one full turn, and then we'll go back there and then make another turn. Then this turn is the one that then completes the negative 420 degrees. So you see now that for negative angles, I'm doing my turns going counterclockwise. And clockwise, I mean, here I was drawing my angles going counterclockwise, and here I go clockwise to draw negative angles. And this is how we do it. So all the time, if they say represent angles in a Cartesian plane, this is simple how you go about doing that. So the only thing that is left for you is just to practice. So you can practice drawing these angles on yourself and see if you have understood what happens here. So you will have to draw these angles in the same Cartesian plane or a single Cartesian plane like that. So you should draw 57, 144, and then 829, then negative 627, then negative 950 degrees. So just try out to draw these angles in the same Cartesian plane, and then we are going to provide you with solutions so that you can check out if you have managed to do the right thing. Otherwise, that's the end of today's lesson. See you next time for our part 2 lesson, where we are going to be discussing trigonometric functions and many other things that are associated with them. Thank you.